Hello friends, I'm Engineer Nasir. In this video, I will explain you how to select the duct riser support. Normally, we use two types of support for the duct riser. First, we make angle or channel reinforcement with the duct and we support this reinforcement with the slab. Second, we fix cantilever support with the wall and we hang the duct with it. First, we will select the duct riser support using table given in SMACNA. Then we will do a general structural calculation for other sizes. To select the angle size for duct riser support, we use this table. As per this table, up to the duct size 1200 into 610 millimeter, we use an angle 38.1 30 into 38.1 into 3.2 millimeter. Then up to duct size 1500 into 750 millimeter, we use an angle with size 38.1 into 38.1 into 4.8 millimeter. Then after this, up to duct size 1500 into 1500 millimeter, we can use two type of angle, 38.1 into 38.1 into 6.4 millimeter or 51 by 51 into 3.2 millimeter. For duct size above it, you need to make a structural calculation. To calculate the number of fastener for duct riser support, we use this table. Up to 406 millimeters duct size, we use two number of fastener. Then up to 610 millimeter size, we use three number of fastener. Then above this size, we divide the duct size by 8 if the size is inches, or if the size is in millimeter, then we divide the duct size by 200 to get the total number of fastener. And locate one fastener on each side of duct up to a distance of minimum 50 millimeter. Suppose we have duct riser size 700 by 400 millimeter and we need to provide support for it from the slab. If the height difference between two slab is 3.7 meter or less, then you can select the angle size for its support from this table. Our size 700 by 400 millimeter, which is less than the first size here. So we can select this angle 38.1 into 38.1 into 3.2 millimeter. But if the height difference between two slab is more than 3.7 meter or the duct size is bigger than the last one, then you need to make a structural calculation to select the angle or channel size for this duct support. For duct riser, you can use two types cantilever support. Up to duct largest dimension 600 millimeter, you can use steel strap like in this picture. And for above size, you can use steel angle or channel as shown in this picture. For cantilever support up to duct size minimum 450 millimeter, the minimum steel strap size is 38.1 into 1.61 millimeter, and up to duct size 600 millimeter, minimum steel strap size is 25 into 3.2 millimeter. And to select the angle size for duct cantilever support, you can use this table. For a duct size up to 900 millimeter, you can use an angle size 25 into 25 into 3.2 millimeter. And for a duct size up to 1200 millimeter, you can use an angle of size 31.8 into 30.18 into 3.2 millimeter. And for above duct size, you need to make a structural calculation. Assuming we have a rectangular duct with size 850 into 600 millimeter, then to select the angle for its cantilever support, we will use this table. From this table, we found that 850 size is coming in the range of 914. So for its cantilever support, we will select an angle 25 into 25 into 3.2 millimeter. Similarly, for a duct size 500 into 300 millimeter, to select an steel strap for its cantilever support, we will use this table. So you can see 500 is coming in the range of this 610. So we will select an steel strap for its cantilever support of size 25 into 3.2 millimeter. To select the anchor for duct cantilever support, we use this formula for tensile load equal to 3 by 8 into duct weight divided by 4, and shear load equal to half into duct weight divided by 4. To select the riser support for a duct size that is not given in a SMACNA table, we will do a sample calculation here. If you need to select the size for duct support from slab, then we need to know three things. First, duct size, that for our sample calculation we assume 1600 by 800 mm. Duct sheet gauge to calculate the duct weight, which we assume 18 gauge, and the height difference between two slab, which we assume here 3.5 meter. Duct size is 1600 by 800, gauge 18, and unit weight for gauge 18 is 10.52 kg per meter square. Height difference between two slab is 3.5 meter. And the total area for a duct length of 3.5 meter is 16.8 meter square, and total duct weight for a length of 3.5 meter is 176.74 kilogram. As we use two number of angles on each slab for duct riser support, so the total duct weight that will be supported by one angle will be half of the total duct weight. 176.74 by 2 equal to 88.37 kilogram. Clearance between shaft and duct riser on both sides, let us assume 75 millimeter. We will use this table to select the properties for angle, and we found that angle with size 75 by 75 by 5 millimeter is suitable for our duct riser support, so we'll do sample calculation for it. The first column is for the angle size, and from this column we can select the cross sectional area for the angle, and from here we can select the moment of inertia, and this column is for section modulus. So for angle size 75 by 75 by 5 millimeter, cross sectional area is 7.37 centimeter square, and moment of inertia in centimeter is 38.7. The value for section modulus of this angle is 7.02 cubic centimeter. To select angle or channel for duct riser support, we make three calculations: deflection, shear stress, and bending stress. We will do calculation for deflection now. Angle length inside the shaft is 1750 as duct width is 1600 millimeter, and clearance between shaft and duct on both sides is 75 millimeter. Then the total length of angle inside the shaft will be 1750. For this duct riser support, we will use an angle 75 by 75 by 5 millimeter. Section modulus for this angle is 7.02 cubic centimeter. Moment of inertia in centimeter is 38.7, and cross sectional area for this angle is 7.37 centimeter square. When we apply this value in this formula, we found deflection in this angle due to this duct weight equal to 1.875 millimeter, and the allowable deflection for this angle length is 4.86 millimeter. So as per deflection calculation, this angle is safe for this duct riser support. Now we'll do calculation for shear stress and bending stress also. As per shear stress, maximum allowable duct weight for this angle is 7770 kg, and as per bending stress, maximum allowable duct weight for this angle is 169.16 kg. As these two weight are more than our riser duct weight, so as per shear stress and bending stress also, this angle is safe to use for this duct riser support. Now we'll do the sample calculation for the same duct riser for cantilever type support. You can see for cantilever type of support, no need to make clearance between support and duct. We can attach the angle with the duct on all four sides. For duct riser, this dimension is 800 mm and this one is 1600 mm. Duct size is 1600 by 800 mm, gauge 18, and unit weight for 18 gauge is 10.52 kg per meter square. And we will use the height difference between two duct support, 3.5 meter. Then the total duct weight for 3.5 meter duct length is equal to 176.74 kilogram. As we will use two angle for one support, then the duct weight for one angle will be equal to half of total weight, which is equal to 88.37 kilogram. कैंटिलीवर सपोर्ट के लिए हम ये यू चैनल यूज़ करेंगे 75 बाई 40 बाई 5 मिलीमीटर। इससे पहले हमने एंगल के लिए कैलकुलेशन की, लेकिन उसमें बेंडिंग स्ट्रेस की वैल्यू ज़्यादा हो जाती है, तो एंगल को हम इस डक्ट की कैंटिलीवर सपोर्ट के लिए यूज़ नहीं कर सकते। इस यू चैनल के लिए क्रॉस सेक्शनल एरिया है 8.818 सेंटीमीटर स्क्वायर, मोमेंट ऑफ इनर्शिया की वैल्यू सेंटीमीटर में है 75.9 और सेक्शन मॉडुलस की वैल्यू है 20.2। First we'll do calculation for deflection. The duct dimension beside the cantilever support is 800 mm, so we will consider the length equal to 800 mm. And for one support we are using two cantilever channel or angle support. So the duct weight supported by one cantilever support will be equal to half of total weight, which is equal to 88.37 kilogram. And we take 50% safety factor for duct flanges and reinforcement. Then after adding 50%, the total duct weight became 132.56 kilogram and in Newton 1950 Newton. Section modulus for this U channel is 20.2 cubic centimeter. Moment of inertia in centimeter is 75.9 and cross sectional area for this channel is 8.818 centimeter square. When we apply these value in this formula, we found the deflection in this U channel due to this duct equal to 0.82 millimeter and allowable maximum deflection for this channel length is equal to 2.22 millimeter. So as per deflection calculation, this U channel is safe to use for this duct riser support. Now we'll do calculation for shear and bending stress. As per shear stress, the maximum safe duct weight for this U channel is 4648 kg, and as per bending stress, the maximum safe duct weight for this channel is 266 kg. Both of these weight are higher than our duct riser weight, so this channel as per shear and bending stress also is safe for this duct riser support.